Well, hello friends. Today we are going to try to do reverse DNS lookups, and that's because when you do a DNS lookup, it only goes one way currently, so we can do like host google.com, but then if we take the IP address that they give us and ask for what that is, it just tells us, hey, it's this IP address. And if I do the same thing on my host system, then, well, one thing is I get more info, but I also am able to reverse look up this thing, and it gives me this pointer, which is just what the name is basically for that IP address. So I'm not exactly sure how that works, so first thing we're going to do is just look into it. So how does reverse DNS lookup work? Yeah, blah blah blah. Okay, so it uses the special domain in -adder ARPA, and it's the sequence of the numbers, and then you append the suffix, split the IP address into octets, and decimal numbers, blah 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 blah. Least significant octet first. Alright, so basically we just take the IP address in Intel byte order and then append in adder ARPA, look it up, and then get a PTR record. Okay, I think we can do that. So let's go to the lookup server app. And I'm just thinking, how do we even call this thing though? Because I guess I have to look that up too. Reverse DNS lookup C API. How do you do that? Get host by adder? Is that what we want? Get host by adder. Guess that would work. Let me just look that up in POSIX. Get host by adder should return an entry of blah blah blah. Wait, hold on, but a host end can have a name. Yeah. Alright, so let's do get host by adder then. That would look like what were the arguments? Host by adder. Oops. Okay. Oh, shit, not you. Right. I guess the type is, what is the type? Is it AF INET? Right. Okay. And let's do this part first. With let's do the C library part first. So let's see, get host by adder, const void, sock1t adder thing, size, let's call it, and int type. Okay, and then we'll say if type is not AF-INET, then I can't help you. Setting address family not supported. What the hell is the name of that error? Address family not. What the heck's it called? Oh, EAF now support, right? That's the one. Okay. Then we don't need to do all this gunk. Okay, so now what we're going to do here is we're going to connect to the lookup server, which is the local server that's responsible for talking to DNS servers. So here we're just connecting to him, and then this is the message that we're going to send to the lookup server. So I'm actually going to tweak the existing message because currently there's only one type of request. It's like do a DNS lookup of this name. But that's going to become like, I guess, a request type. We'll call it like, what do I call it? Like a lookup, like L. And this will be like a reverse lookup, so R. Cool. Okay. And now we're going to have to put the IP address here. So, oh, wait, shit, hold on. I don't have to change the format because I'm just going to do a lookup of a different kind, of a different name, but we're going to auto-generate the name, so I don't need to change the command format, I think. So let's just try that trickery instead then. In address.arpa. Okay. Then let's see. If adder size is less than size of an in adder. Oh, okay. In adder. That's not valid. Oh wait, no, we're not in the kernel. So let's do that before anything else, actually. Okay. And then we can do something like, oh, do we already use IPv4 address? Yeah. So we'll just give it an adder. Is this possible? What does an in-adder look like anyway? Oh, right. IPv4 address. Does it have a... No. Okay, well, we'll just give it... we'll just do this. So I'll say const byte. A byte doesn't really matter. Do we need to do something like that? But I mean, it's the first in the thing. It's not the end of the world. Okay. So we can do const. That's kind of a hideous line of code, actually, but whatever. Okay, so come here now. Let's do this. And oh, it was supposed to be reverse order. So like that. Cool. And then we just do all the regular stuff. I mean, we're gonna have to look at what this thing is actually, what kind of response we get from the server, and then we have to figure out what to do with it. But at least we can set up so that we get as far as sending the request, and then we can look at what the response looks like and figure out where to go. Okay. So I guess we can't do this. That's now the name is going to come over the wire. So we're reading into this buffer, and previously the buffer would be the IP address. Now it's going to be a name. So I guess actually we can do this. Stern copy. Well, what the heck? I should know this, but I don't remember it exactly. What num does, maximum number of characters, right? So we would say something like maximum number to copy is the number received, right? And then how big is that buffer? So okay. Okay, then we set up the name. We shouldn't do this part. And I think we're good. This stuff though should be like I guess, how the hell should that work? I guess it should have the IP address that we provided in a what? In a socket or in, I guess. Let's just put that as a fixed me. Just do this for now. Yeah. Okay, whatever. And I think that's cool. Like right now, these two functions are sharing a buffer and everything, but it's probably okay. Well, maybe we should give them each their own buffer. Otherwise, things would just get a bit messy. And these, we're going to rename these to get host address buffer, right? Oh, I guess I should have one of those actually. But by name, am I forgetting it somewhere? No. Okay. Fine. I think that's hackish enough. So how the hell do we use this? Let's see. Can a host name start with a number? Things I should maybe know. A valid host name can never have this form. I'm just thinking, like, how do we figure out if something is an IP address? I guess we can try to convert it from an IP address. And then that we would use inet p to n, right? And we're already using that somewhere, so I can just try to do this. Okay, so let's see. Alright, so let's see, what do we want to do here? We want to figure out if this is an IP address. If this looks like, if input looks like we should do a reverse lookup. We'll just rename this one to pattern. And here we can just say RHV1. Okay, and then if RC is 0, then it's then we do a reverse lookup. Okay, or we can keep the comment actually. Right. We can print hexadecimal IP address. Okay. We'll say auto hostent is get host by adder, which we want. If we don't get a hostent, I should say standard error actually. Lookup failed. So the first lookup failed. Get host by adder. Right. Because I'm not supposed to pass in RHV1. I'm supposed to pass in the and then that's the size of an adder if inet. Okay. And if it succeeds, then we'll print name. I hope this makes sense. Well, I feel like this might be reasonable. we'll see how it goes. I guess what I could do is just try this try this program on Linux. Fooz. Oh man. I should probably rename that to CPP. Google.com. Well, you're not supposed to do a reverse lookup for that, so we already failed. P10. Returns 1 on success. Oops. See, that's very silly. Do I even know that in other places I use this code? Oh, look here, we don't even care. Yeah, so these are wrong actually. I mean, these are just tiny little test programs, but let's put this here anyway. I guess we can continue with, let's just go ahead and verify that this thing works. And if we say doing a reverse lookup for that, and yeah, okay. So this program works on Linux. Then we should just try to make it work on Serenity. Google.com, host 216.58.207.238. Segmentation violation, well. So we're crashing because we're reading an invalid address here. Let's find out why that's happening. Okay, so host and get host by header. And it's before string format, after close. So we're here. Okay. Oh shit. I guess we are interpreting the IP address as pointer. That's not what I wanted to do. I guess I wanted to do that. Okay. So let's make a command for this. So let's say rm userland host and userland host and sync and run. Oh, oops. Still running. Can't overwrite the image while it's running. Yeah. Well, wait a minute. You didn't try to do a reverse lookup there. I feel like it's not trying anymore. Let's see. Oh, see, because our version of initptown is not well behaved. So we should return 1, and what the heck was the other condition? If does not contain a character string. Oh, I see. So here this should be 0. Because if the protocol is invalid, it's this, otherwise that. Maybe we were not supposed to clobber enval in that case. Well, whatever. Or clobber, or no. It seems like it's probably not the most important thing. Okay, so what did we do here? Now we got as far as sending lookup request. Got a request for this address. And let's see, question count. We got a response, but it doesn't have any answers in it. Okay, well, I guess we should look at the lookup server. I haven't looked at DNS stuff for a while, so let's see. DNS question format. Record types. So we wanted a PTR record. So is it that we are not asking for that in lookup server now? Don't remember how I wrote this thing. I mean, I remember doing it, but I don't remember exactly how it worked. So the question count is this. And then what? Cin. So where do we ask for the PA? I guess we should ask for the tputter as well. So can we do something like this? Will that give us multiple records? Let's see. So it's the name, the type, and the class. Maybe I can only do I mean, these things don't really look like they're supposed to be ORed together, because a bit is set in others. So let's just try this then. Tputter. Oh, and I need to remake the lookup server as well, actually. Servers, lookup server, clean, and let's see, servers, lookup server. So maybe I do need to have a custom message for this. So okay, so what happened? So we got a request for the lookup server. So we got a request for the lookup server. So maybe I do need to have a custom message for this. So okay, so what happened? So maybe I do need to have a custom message for this. So okay, so what happened? So got an answer. Mm-hmm. Okay. So that works. And this thing should probably just work differently. So let's make a copy of this. Let's copy this gigantic thing. We'll work out what the differences are and then we can share code later. But first thing, let's just make this work. So we'll just make one that we call reverse lookup. And it will have a vector of string instead. What type's the DNS IP? Oh, so name server. Okay, well, it's not the best name, but we'll keep it for now. So for reverse lookup, we want to get a putter record, and we want to return strings, not IP addresses. So for each answer, I guess if it's a putter record, then record data, but how do we know how long the record is? Oh, data length. Okay, well, that's straightforward. Let's see, so let's say name, record data, record length, data length. I wonder if it's really this simple. Oops. We did a reverse lookup. Oh, right, but we're not running that code. Okay, so we're gonna need those custom types. So this one should be, the normal lookup should be L for lookup, and then the other one could be %R for reverse lookup, I was thinking. And does this thing even send a request? Oh. Phone's buzzing. Wait, we connect and then what? Oh, wait, back up. I'm stupid. Okay, right. This is where we do the thing. So this should just be R. Right. And then in the lookup server, we have to peek at the first byte to see what kind of request this is. So let's see. Addresses. So maybe, well, guess we should always do this, and we'll call it responses instead. Response. And then we can make this guy also return a vector of string. And here we'll just append toString. Okay, I think that's cool. Lookup. And here we say client buffer +1 and receive -1. And say lookup type is if it's not lookup and it's not reverse lookup, that would be lookup type and we'll close the client and we'll continue. And that goes in standard error and you open a brace. Okay. And then here, if lookup type is regular lookup, okay. Look at that. That it looks like we're actually getting somewhere. So that appears to be the name I'm looking for, although it looks a bit strange, but we'll figure that out. So let's see, let's just verify that the old stuff still works. Yes, it does. Okay. That looks very interesting. So let's see, what's the answer? Answer records, name. So I think the name field is like, that's what you asked for, right? Oh, wait, no, the dashes are fine. We should just put dots in between. So, no answer. Sorry, I'm a little bit. It's early morning here, so I'm a little bit groggy still. I think this is the resource record specific data. What's the binary formats? For a PTR, it's the name, right? So I guess these things are just, we should just dotify the response, basically. Do we have something that already that does this? We have splitting on dots, parse DNS name. So how does this work? Parse DNS name. I guess we can try this function, see what it does. Okay, so that was a reverse lookup. We'll do something here like instead of that, we'll do auto name, parse DNS name. Let's say record data. Max offset. Wait, what the heck is the offset? I don't understand how this thing is being used. Offset is 0. Oh, I see. So it's like, how much did you extract? So I guess the max offset is like the record data length, and then send offset 0. Okay. Well, that looks just right. Cool. Question is this, answer is that. Well, that's pretty dandy. Okay. So, does the name contain a new line at the moment? Because that's a bit weird. So, where does that come from? Did we do that somewhere? No. Data length. Okay, well, I guess we should try to share code here, because this is like absurd how much they have in common. It's really just this thing here that changes. And then we handle the record types slightly differently. So we could just do all this gunk inside of it instead. Name, characters. Oh yeah, so then we can just do this last part here. We'll do that in here. So we'll say data. And we'll do that here instead. We'll say like debug printf data. Oh, just like that. Name, characters. Okay. And we'll do this in here. And you come with me. I'll put you here too. Okay. And else if record type is TA, then we do the TA thing, which was this. So it's like that. Print it that way, so just print. Okay. This one is just a temporary offset actually, so I don't care much about that one, I think. Because we already know the record length anyway, so we don't need, yeah, okay, well, don't worry about that. So maybe we should do something like, no, let's keep it like an if, because otherwise we're creating new variables anyway. I was thinking of making a switch, but that would get kind of ugly, so. Now the thing that's left remaining is the lookup type. So we can say that. What do we call it? We just put a short, I guess, unsigned short. Record type. Call it lookup, and we'll say. Okay. Record type. Okay, and now here we're going to put TA for the regular ones, tputter for these. Then I think we can get rid of the old one. And see how that works. Cool. That's very cool. But where the heck is that new line coming from, though? Data is this. Okay, well, let me just. Let me do it this way at least so I can see that it's actually coming through. I mean, yes it is, but I just want to confirm it. Yeah, okay, so the new line is in the H name, sure. And we are setting that here. Name buffer. So we're taking everything we received. I guess we are receiving it with a new line at the end, actually, because why wouldn't we? I'll say if. Yeah, right, because responses, and then it just uses the new line character to separate the responses. So we need to know about that. The client side, that we should just in get host by adder, we need to just ignore the new line. It says here, we can do something like if receive is greater than 1. We'll just do we'll just do that. It's kind of a lazy solution, but oh wait, let's. Yeah, there we go. Okay. Let's try it on something else, like dictionary that I sometimes use for name lookups because it's short. 85, 60. And let's just verify this over here that, yeah, we still don't do all of those, but we can verify that that is indeed EU Central 1 Compute Amazon. Yep. Cool. Okay, let's do a little bit of a patch review. People are sleeping, so I'm trying to be a bit quiet. So what did we have? First, oh yeah, it's fixing up the behavior of inet piton. Let's do that in a separate patch actually, because I guess we can fix that one as well. You see, these are just some UDP and TCP test programs that I made. ARPA inet. Okay, let's say libc return 1 on success. Okay. Make this a bit bigger. Alright. Then what do we have? So now we're adding the get host by adder to NetDB, changing the format of the lookup server requests slightly. Okay, so here's get host by adder. I guess we could wrap this stuff in a helper. Let's see. All of this gunk here is basically like connect to lookup server. So we'll make to lookup server return FD. Yeah, and then we can just do, instead of doing all that, we can just do like this. That will save us some lines, and it's silly to not share this code. Then the rest is a bit more specific to the lookup types. And I guess we need to define that. Okay, or declare, rather. Just verify that everything still works. Yeah, okay. Diff, right. So now we're sharing the code for connecting to the server. Where did that go? Oh, it's right here. Connect the lookup server. Right. So that's all the same. Get host by name doesn't really change otherwise. Inet piton. Guess we should actually do that here. Yeah. Okay. So this is get host by adder. First we check if it's not AFINet, then we don't support that. If the adder size is too small, we don't support that. Then we connect to the lookup server. If it doesn't work, we fail. And errno will be set somehow appropriately, I guess. Yeah. I don't know what we should say. Well, it doesn't matter. We'll get an error message and we can figure it out from that. Okay, so then what we do is we say do a reverse lookup of the IP address .inaddr.arpa. And it's in Intel order, or little endian. And we send the request. And I don't know why it says send here when we're using write. I guess we could be using send, but we are using write. So we should probably say write. Yeah, that's okay. And then we take the response and strip off the new line. And like this code isn't like very paranoid about inputs right now. It's something that we should change in the future for sure, but like right now this thing is built to work, not to handle every possible crazy input, right? You understand what I mean. Okay, so we receive that, and then we copy the buffer that we receive. We just copy it into the name field of the host entry. And then this is just a fix me, because probably we should fill in more parts of the host end, but I'm not going to fix that right now. Okay. And then here's just adding it to the netdb header and libc. Okay, and then in lookup server, we are extending the lookup function to now also take a record type. And here, when we get a request, we check if it's either L or R. Otherwise, we say, oh, it's not even a valid type. You crazy person. Should probably say lookup server first. And since I never actually read standard error of that thing, I'm just going to put it on the debug printf instead. Okay. Then the hostname it's one step into the client, because we have to skip over the lookup type character. Right. And receive. I guess if and receive is 0. It doesn't matter, okay. Then the responses, changing it to a string vector because now we might get some different types of responses, right? Okay, and then depending on the lookup type, then we ask for either an A record or a PTR record. It's cool. And yeah, this is just changing them to the string vector return type instead. Right, and then here's lookup. And that's not up to lookup server. I think that's up to the client code. Okay, so here now we send them specified record type instead of hardcoding TA. And then down in the bottom, we are going to accumulate a vector of strings. And then we branch on the record type. Record type, and we can say like else debug printf. Unimplemented. And we can also say lookup server fix me handle record type u. let's record type. Okay. Cool. Yeah, and then for PTR ones, we just call it parse DNS name, which turns it from that zero byte delimited, or 0 byte delimited. Is that the word? I think that's the word. String, and turns it into like a human readable name. Cool. And then here is the additions to the host program. So if we try to convert the input from like an IP address string to an IP address, and if that succeeds, then we have an IP address. And then if that happens, then we call get host by adder, and then just print out the host name. I think that's basically it. Cool. Let's commit this. So let's say lookup server plus loopc plus host, I guess. Or server plus loopc as for reverse DNS lookup. Yeah, get host by adder. This is what it was called, right? Get host by adder, yeah. Lookup server can now take 2 types of requests. L. Okay. Old. Reverse lookup. Right. How do we format this? That's pretty nice. The bin host program now does a reverse lookup if the input string valid for address. Cool. Very cool. Let's see that one more time. Host github.com. Host. It works. Very cool. All right. I think I'm gonna call it a day, or the day's just starting, so I'm just gonna call it a video. But if you made it this far, then I thank you for watching and for coming back. And I know that I haven't been as frequent with my uploads in the last couple of days, and that's just because I've been working and I'm still getting used to that, but I think this is going to be okay. I think it's going to be good, I think. And yeah, so thank you for hanging out with me again while I hack, and I will see you next time.